All right, remote calculus and calculus in general here. Got a little notes video for the end of chapter 1. Here's a question that we sometimes struggle with in this semester, really, when we're talking about inverse functions here. So first off, remember, cotangent is the reciprocal of tangent, secant's the reciprocal of cosine, and cosecant is the reciprocal of sine. Also, cos inverse, sine inverse, tan inverse, when they're positive ratio, you're going to draw an angle in the first quadrant. Okay? We're dealing with the first quadrant angle there. Sine inverse and tan inverse are both negative there. I'll give you a negative ratio in the fourth quadrant. Again, you can always check, sine inverse of negative 1/2 would have to be a negative 30 degrees, which is here. Yes, negative 30, exactly. Then cos inverse, it's negative in the second quadrant. If you do a cos inverse of negative 1/2, you get 120 degrees. That's in the second quadrant. So it's important that we know that for our upcoming quiz, where they're all at. Your calculator can help you a little bit. All right, so example 1 here, find the exact value of secant of tan inverse 5. First off, tan inverse 5 is 5 over 1. It doesn't matter what trig function we're looking at. We're looking at here, it's got to be the first quadrant. Positive ratio, 5 over 1's got to be in the first quadrant. So again, this is a theta. I'm looking for secant of a theta that has a tangent ratio of 5 over 1. Always make the right angle with the x-axis. Theta is always coming from the origin there. So tangent is opposite over adjacent. Pythagorean theorem here, 1 squared plus 5 squared gives you root 26. So remember, secant is the reciprocal of cosine, so let's figure out what cosine theta is. Cosine theta is adjacent over the hypotenuse. So secant theta is the reciprocal of that. It's root 26. All right. Let's look at number 2. On 2, we have cosecant of cos inverse negative 3/4. Cos inverse negative 3/4. Cos inverse negative in the second quadrant. There's theta. 3 and 4 adjacent hypotenuse. 3's got to be negative because going to the left in the second quadrant, x is negative. Pythagorean theorem would say negative 3 squared plus y squared is 4 squared. You can also do 4 squared minus a negative 3 squared. You're going to get a positive root 7 for that side. Okay. It's positive. You're going up. Second quadrant, y is positive. So cosecant's the reciprocal of sine. So sine theta is root 7 opposite over the hypotenuse. So cosecant is 4 over root 7. Multiply the top and bottom, on your homework, rationalize the denominator, 4 root 7 over 7. On a quiz, 4, because the time 4 over root 7 is fine. Okay, again, pause this whenever you need to. Let's take a look at 3 and 4. All right. Cosine tan inverse of 2 over 7. So what do we got here? Positive 2 over 7. Everything is positive in the, we don't want that. Everything is positive in the first quadrant. There's theta. Always make a right angle with the x-axis. Theta always coming from the origin there. So opposite over adjacent, it's root 53. Opposite over adjacent, Pythagorean theorem, gotta know that. So what do we got? We got cosine of theta is 7 over root 53, which 7 root 53 over 53. Multiply top and bottom by root 53. Okay. And then on 4, we have sine of secant inverse -2. Now this one's interesting because the reciprocal function, I want the inverse of that. So this is no bueno. Instead, I'm going to write it as sine of cos inverse -1/2. If secant is a -2/1, then cosine, its reciprocal, is a -1/2. So that's very fair. That's very fair. So cos inverse of -1/2 is secant inverse of -2. Second quadrant, cos inverse negative in the second quadrant. There's theta, right angle made with the x-axis. So I didn't give you one in the fourth quadrant, but if you had tangent inverse of a negative, which I probably meant on this one, quite honestly, it'd be in the fourth quadrant. Sine inverse of a negative, it'd be in the fourth quadrant, and you would make it like this. There's the right angle, there's theta, if we were looking at the fourth quadrant. All right, so just be on the alert for that. That's fair game on your homework and next quiz and exam. So -1, 2, this is √3. This is special 30, 60, 90 triangle. Sine theta is √3/2. Okay? Anyway, we did those 4 in class exactly like that. So I went over 5. This one's on your homework set, and it's one that I went over, one just like it, I went over on Wednesday and Thursday in class. So you have x to the 2/3 times x to the 3/5 times x to the 1/2. The square root is the 1/2 power. Now I have the same base, so I can add the exponents. First I want to get the common denominator. On your homework show this. Common denominator is 30, so 20/30 times x to the 18/30 times x to the 15/30. All right. Same base, I add the exponents. 20, 18, 15, add them up, you get 53. 30 as the exponent. Don't forget x is the base. I've had students just say it's 53/30. No, that's the exponent. X is the base. X to the 53/30. All right, that's a good one for us to know how to do. Then we got a difference quotient one. And difference quotient has presented a problem for folks. We're getting better at it, but we can't throw up our hands for sure. Right? We got to get this one right. I'm going to do f(1) off to the side. So f(1) is going to be 7 minus 5 times 1 minus 4 times 1 squared. Doing f(1) completely by itself. 7 minus 5 minus 4. Oh, this is good. -2. f(1) is a -2. So what we're going to do here is f(1) plus h. 1 plus h is going to be plugged in for x there and there. All right, so this is going to be 7 minus 5 times 1 plus h minus 4 times 1 plus h squared. That is f(1) plus h. Then minus, and in parentheses, f(-1), or f(1) is a -2. Put that in parentheses. Do the work first. Put it there. Too many people are putting all the work there, and they're making errors with the minus sign. Okay. Over h. Now it's time to do a little simplifying. So we got 7 minus 5 minus 5h minus 4 times 1 squared plus the inner product is h doublets. To subtract a negative is to add. Again, we're dividing everything by h. Then, we're running out of room a little bit. Simplifying time. Where are we at here with room? 7 minus 2, that's just, or 7 minus 5 is just 2. Minus 5h minus 4, I'm distributing, minus 8h minus 4h squared plus 2. Everything's divided by h. 2 plus 2 minus 4. You've clearly shown me that the constants are going to cancel there. Negative 4h squared minus 13h divided by h is a negative 4h minus 13. Final answer, which if we take the derivative, plugged 1 in, that's exactly what we get. Awesome. So you'll see this a lot this year. Lots upcoming. All right, have that down, and we're going to go to the last one here for your video. Write as a single log. So this one's a dandy. Okay, this is natural log, 3 natural log x y to the 1/2 plus 2 natural log x to the 4/5 y to the 2/3 minus 4 natural log x to the 1/3 y. We have powers that need to be brought on up. Okay, so this is going to be natural log x to the 1st, y to the 1/2, everything to the 3rd, plus natural log x to the 4/5, y to the 2/3, everything squared, minus natural log x to the 1/3, y to the 1st, raised to the 4th power. Then we got power to a power. You multiply the power, so x to the 3rd, y to the 3/2, plus natural log x to the 8/5, y to the 4/3, minus natural log x to the 4/3, y to the 4th. All right, in the log world, so we did the power property there. In the log world, addition means multiplication. This times this. I'm going to do that first. So natural log of x to the, so if I'm multiplying, I'm adding the exponents there. That's 15/5. 8/5 gives me 23/5. Y to the 3/2 times y to the 4/3 is going to give me something over 6. Add the exponents, that's 9/6 and 8/6. 17/6 minus natural log of x to the 4/3, y to the 4th. In the log world, subtraction means division. I can put them together now as a single log. Natural log, again, natural log is log base e. Natural log of x to the 23rd fifths, y to the 17/6, divided by x to the 4/3, y to the 4th. Okay, so then I ask myself, what has, in terms of the top or bottom, where's the highest power for x? It's up top. 23/5 is bigger than 4/3, so this common denominator is going to be 15 here. 3 times 3, that's 69. Times it by 5, that's 20. So 49/15 is the rational exponent. Down below, you have more y's. That's, in fact, that's 24/6. So y to the 7/6 down below. And this one does require a lot of work, and I want to see a similar amount of work there. Okay, you know, while we might as well try one more of these. So let's do this one. Find the exact value. All right, you can't see that. How about cotangents of cosecant inverse -3/5? Give us a nice 3, 4, 5. Oh, no. First off, That would mean, I made a mistake there. That would mean sine is bigger than 1. That's what I meant. All right, or less than 1, net less than -1. So the ratio can't happen. Sine cosine ratios between -1 and 1. You can see that on the unit circles. First off, cotangents of sine inverse -3/5. All right. So sine inverse negative in the fourth quadrants. You can type in sine inverse -3/5. You get a negative angle between 0, -90. Opposite hypotenuse. This would be a 3, 4, 5 triangle. 4 is positive there. Okay, so cotangent is the reciprocal of tangent. So tangent is a -3/4. So cotangent would be a -4/3, and that would be my answer, -4/3. All right, folks, that definitely catches you guys back up. This is Yak Math Videos signing out.